असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतंगमय। ॐ शान्ति शान्ति शान्तिः।
Namaste, my dear young friends. From today, in my videos, I want to start with physics ideas. Especially in today's session, we start with 11th standard mechanics, that is motion in straight line. In fact, the idea is many of us, in fact, very large number of students simply start thinking of the sentences. In fact, you may know one saying there. Say what we can say in hundreds of words can be said in one figure. So that's also true with our memory also. Instead of remembering the say sentences, remembering the physics in the form of sentences, that's always a bad thing in one sense. Try to create the imagination in your mind. To help that, I am bringing the concepts as much as possible in the form of pictures. Now I start with today's session, I start with motion in straight line, basic concepts and the imaginations. After that, then and there itself, we try to learn to apply the things what we learned in the form of MCQs. So we start with the thing. Motion in straight line. Observe the motion. The word indicates what? And also remember, as I said in one of my study methods videos, we must ask the questions whenever we listen something. We must create the imagination whenever we listen something. Then only we will be able to understand. That's what we call as understanding the ideas. Now I said motion in a straight line. First word, motion. Motion means what? That should come into our mind. Even though it's simple, it seems to be simplest. But once we start asking from the simplest, as we proceed, we go to the complex, and all those things will be learnt in this manner only, and we are ready to apply the ideas what we learnt at any moment. Okay, now motion in a straight line. Motion means change in position. Say you are in the college early morning at 10:30 and you came home at 3:30. Your position from college changed to your home. So there is a change in position. So you have moved all the way from college to your house. So motion means change in position. Motion implies change in position. In fact, as I said, you need not remember this. You just create a imagination like this, where you mark your house and where you mark your college. Simply imagine these things in your mind. You try to create the picture. Then you traveled all the way to here, college to house. So your initial portion is college now. You can start from the house itself, but we start initial position like this. Final position is your house. Therefore, motion, as soon as you hear the word motion in straight line, first part, change in position, wherever, even motion in plane also, which we learn in due course, motion in plane or motion in straight line. In both the things, motion, what means change in position. Don't keep that in mind. Try to keep this example in mind. Try to close your eyes and create an example. Oh, you have come from college to house. So college is your initial position, house is the final position for that day. So college to house, position, change in position. Final position is your house, college is initial position. Now, once you learn these things, next idea is displacement. And in fact, in a new syllabus, new textbook of NCERT, these are all left. We straight away start with the velocity for the sake of completeness. I am saying displacement. These are all learnt in ninth. Okay. Now, displacement is change in position. Again, motion is change in position. How to measure it? Change in position, that is, displacement is always final position minus initial position. Always this is true. Final position minus initial position. Only that much, nothing extra. Initial position. Final position minus initial position is displacement. Here, final position, if you imagine they are on the same road, your college is in same road with on your where your house is also there. Then, if you take final position as xf, initial position as xi, I stands for initial, f stands for final, or else sometimes we write x1 and x2 also, as we write in textbooks, x1 and x2. Therefore, x2 minus x1. We imagine they are on the straight line, only one number is required. At what position your, say, college is there, at what position your house is there? X2 minus x1. This is what we call as displacement. But observe, if you imagine to measure the distance from an origin on a straight line, displacement may be positive, may be negative. That's why we say displacement is also a vector. You know, vector is a quantity which has both direction as well as magnitude. Okay, once you learn displacement, what you think of displacement, just in this figure itself, imagine x2 minus x1, final position minus initial position. That is enough. Not much is required. But next point, displacement is a vector which can have positive, negative, or zero. Okay, values. Okay, done. Once you know displacement, we proceed on to the next idea, velocity. Velocity. Velocity is rate of displacement. How quickly displacement is changing. Say, we imagine like this. Say, in a car, we are sitting. Car is moving at 30 kilometers per hour. Every hour it covers 30 kilometers. That is what we call as rate of displacement. Every hour, car displaced by 30 kilometer. In fact, in a particular direction, if you imagine to create a straight road where the car is moving in a high express highway like that, when the car is moving at 50 kilometers, say you may object, sir, in the express highway, why should we go with 30 kilometers per hour? Don't bother. We'll increase it to say 100 kilometers per hour. We imagine in our mind, just imagine this. You are, say, in a car on an express highway, straight highway, you are traveling at 100 kilometers per hour. Every hour, 100 kilometers it covers. 100 kilometer per hour rate of displacement. Every hour, 100 kilometer it displaced. That's what we call as velocity. Observe, I write down a picture for that. Just imagine a straight highway, express highway. There you imagine a car or any vehicle. It is moving this way at 100 kilometers per hour, and of this, say this is 100 hour starting when we started counting the time. After 1 hour it covered, I'm not writing it to any scale or something like that, it covered, say from here to here. After 1 hour it covered 100 kilometer, 100 kilometer, and then in the next set also it covers one more 100 kilometer. I may write it here like that. So this imagination should be there in your mind. That's what we mean by rate of displacement. How much displacement took place in 1 unit time. Here I took hour. In many problems, we may take, say, seconds. Okay, so that is rate of displacement. Therefore, rate of displacement is definition for velocity. But the imagination, what you must get in your mind is, just imagine as soon as we say velocity, you are on a highway. Simply for the sake of simplicity, you are in a car or you are in a vehicle, any vehicle, two wheeler or four wheeler, any vehicle. Your car or that vehicle is moving at such and such a speed. So if you say 50, it covers every hour 50 kilometers. So there's displacement every hour. That's what we mean by rate of displacement. How quickly it is changing. It is displacing, here in our case, 100 kilometers every hour. Displacement happening every hour is 100 kilometer. That's what we call as rate of displacement. There are different types of velocities that we come across in the next video, and we learn a lot many things. But remember, try to avoid lot many sentence, try to create very good imagination like this. So I'll come back to that in next video.